Hello students, in the last session we have discussed about displacement, distance, average velocity, average speed and their related formulae for the problem solving methods. So today's discussion is about acceleration and types of acceleration. Okay, so what is acceleration? First one is about acceleration. Acceleration is it's a vector quantity denoted by a bar. It's what denoted by a bar. Yes. Now acceleration is just in generally acceleration when you speak about this, the rate of change, the rate of change in velocity, rate of change in velocity is called acceleration, is called acceleration. The rate of change in velocity is called acceleration. What is the change in velocity? What is change in velocity? Is we can say it's a delta v, vectorially delta v bar is equals to v2 bar minus v1 bar is the change in velocity. So change in velocity, the difference is more, that's what delta v, we are writing this. And next one, what is the rate? Okay, so what is the rate? Rate is means if any physical quantity, it's a physical quantity, so divided by time or time interval. This is about, so acceleration is a bar is equals to, acceleration a bar is equals to delta v bar by delta t. Okay, so this is a required formula for, so for the acceleration. Okay, so this is what I can write it about, a is equals to, so delta v bar by delta t. Acceleration units are meter per second square and centimeter per second square. And what is the dimensional formula of this? Its dimensional formula is, so this we can say L t to the power of minus 2. Okay, so dimensional formula of it is what? Is the m L t power m power 0 L t power minus 2. So this is the acceleration. And what is the nature of acceleration? Nature of acceleration means what? It's a vector quantity. This is vector quantity is the acceleration. And when you speak about the acceleration, yes, so if we talk about this, there are the two types of accelerations we can talk about. One is average, okay, so average acceleration, and next one is about, first one is about average acceleration, next one is what? Instantaneous acceleration. So what is average acceleration? Average acceleration is what? A, okay, so average acceleration is equals to delta v bar by delta t. Okay, so this is about average acceleration. So if you speak about instantaneous acceleration, for the instantaneous acceleration, so instantaneous acceleration is what? Instantaneous acceleration. Okay, so instantaneous acceleration. For the instantaneous acceleration, delta t, this it's seems to 0 but not 0. The difference is delta t. It's what? Very small. It seems to 0. Delta v, v2 minus v1 is very small. Okay. So this is what? A instantaneous is equals to, we can say, limit delta t approaches to 0. It's what? Delta v by delta t is equals to dv by what? It's a dt. Okay. So this we can say as, this is what? It's a instantaneous acceleration. For the instantaneous acceleration means what? Differentiation form. And average acceleration means what? It's an so delta terminology can be used. Okay. So next one, for the acceleration, when you are speaking about it, for example, so there is a position vector is taken. For example, it's a position vector. Okay. Position vector. Position vector is equals to, I can write it as x bar. X bar is the position vector. Okay. So next one, x bar is position vector. This velocity vector, if you want to write velocity, okay, velocity vector is equals to what? It's a v bar is equals to d by dt terminology. D by dt times of what? It's a x bar. And next one, acceleration vector. Okay. So acceleration vector. Acceleration vector is what? It's a bar is equals to which acceleration? Instantaneous acceleration is equals to d by dt times of, it's a v bar. This will become as what? dv by dt. So d by dt times of v means what? You say it's a dx by dt would become as what? d square x by dt square is the acceleration. Okay. So like we can mention, so the acceleration is what? We can write about like in the, what is that, in a position vector, velocity vector and acceleration vector. For example, if you want to write in a 3D, okay, 3D space, in a 3D space, okay, 3D space is what? Position vector is what? For example, r bar I am taking, x I cap plus y j cap plus z k cap. Okay. Velocity vector is what? Okay. So it's what? dx by dt I cap plus dy by dt, it's a j cap plus dz by dt, it's a k cap. So v bar is equals to, we can write vx I cap plus v along with y axis, it's a j cap plus along with z axis k cap. So this is about velocity vector. Okay. So next one, if you want to write acceleration vector, a bar is equals to, okay, d by dt times of, it's a v bar. A bar is equals to dv by dt means what? Same, I can write it as ax I cap plus ay j cap plus, it's a az k cap, like we can write on this. So this is what? Position vector. And next one is about velocity vector. Next one is about acceleration vector. Okay. So this is about what do you say? It's a acceleration. And so you know this one, for the acceleration, instantaneous acceleration. Okay. Next one, average acceleration. So graphically, if you want to check about this instantaneous and average accelerations, so I'm choosing about, so this is what, first x and y axis are chosen. Okay. So this is what, for two different graphs I'm taking as this. Okay. So what is the relation, or what is the difference between this instantaneous and average accelerations? Okay. So this is what I'm taking about velocity versus time. It's a VT graph. This one is velocity versus time. Okay. The graph is given. This is here like a increasing slope. Okay. So the same thing I'm taking about this increasing slope. Two graphs. So just I'm considering on this. I'm taking on here. First one the position. This is the position. Okay. So it's what? This is what you say. It's a T1. Another one at that time it's a T2. Okay. This is what T2. It's a velocity here. This is what V1. Next velocity at this point is what V2. Okay. So if you go on this here, this is what from here to here. If you take about this slope, what is the slope? Slope means here I'm choosing about. So slope means, for example, this is from here. This is okay. You can take about right angle triangle. The slope of this you can write about. This is what it's a theta. Okay, tan theta. Slope of VT, velocity versus time graph. Slope of velocity versus time graph. Slope is equals to what? Acceleration. Okay, it's what? Acceleration. My A is equals to, okay, so this is what? This difference is what? Delta V. This difference is what? Delta T. It's a delta V by delta T, which is known as average. Okay, so it's what? Average acceleration. Average acceleration. Next one, in the same situation, if you move on that, so for the first one, this is what? One position has taken. Yes. Next one is what? Another position has taken. Okay. So these are the things from here, like I'm taking this. See that interval is very small. You can observe the interval is very small. This is what? It's a time T1, here T2, here V1, next what? V2. The graph gives is this. Means here this I can say this seems to what? It's a delta T. Delta T is what? Seems to very small. It's a very small means we can write it's a dt. So this is what? It's a dv, right? So then slope is equals to, I can write, so dv by dt. This is what you say, it's an acceleration. This acceleration is called what? It's a instantaneous acceleration. Yes, is the instantaneous acceleration. This is the information related to what? So instantaneous acceleration, and this is what? Average acceleration. Instantaneous, and next one is about average acceleration. So what are the factors depending on acceleration of a body? Okay, so the factors depending on acceleration of a body. So acceleration of a body. So factors depending on acceleration of a body. Yes, let us see what the factors depending means. What? The acceleration changes. So when the body changes, so then what? The change in velocity may be due to what? So acceleration is produced due to what? Acceleration. Okay, acceleration. So is produces. Okay, this is what? Produces. So due to what? Change. Whenever change in velocity takes place. So when velocity changes, acceleration produces. When velocity changes, acceleration produces. Okay, and for the first thing I can say here, the acceleration when if the magnitude of velocity changes, but direction remains same. Acceleration changes. Okay, if magnitude, okay, magnitude. So just we can talk about this. It's a magnitude of velocity changes. So magnitude of velocity changes. Magnitude of velocity changes. Magnitude of velocity changes, but direction remains same. It's what? Direction remains same. Yes, so direction remains same is the first thing. So also what do you say? Acceleration changes. So magnitude of velocity, if direction changes, okay, so but magnitude of velocity, but magnitude of change in velocity, so changes. Okay, so then also acceleration changes. If both changes, means what? Magnitude and then what? Direction both changes, also what do you say? Acceleration changes. So like we can go for this is what? It's a acceleration. Yes, next one, so just I'm taking about first one question I'm writing on this. This is what? It's the question is about, yeah, we can take about the question is velocity of a particle moving along with x-axis. The velocity of a particle, moving along with x-axis, okay, so the velocity of the particle moving with along with x-axis, v is equals to something I'm taking about, v is equals to 4 minus t square meter per second. Okay, 4 minus t square, it's a meter per second. Yes, so v is the velocity and t is what? It's a time. So then calculate, first one, calculate average acceleration, First one is about average acceleration. When you say average acceleration, so from t is equals to 1 second to t is equals to 3 seconds. So when you say average acceleration, we need to mention t. So from particular t1 to t2. Okay. So next, second one is about acceleration. So this is what? Acceleration. So acceleration as a function of acceleration as a function of time. Acceleration as a function of time. And for a third one, so third one you can write about instantaneous acceleration. Instantaneous, okay, acceleration at t is equals some particular value we need to mention. T is equals to what you say? It's a 1 second, right? So these are the questions. Now first one about, I want to know about average acceleration. Average acceleration means what? This is the condition. From this we can say AVG is equals to V2 minus V1 by T2 minus what? It's a T1. Okay. So what is a V2? So from this V2 means what? V is equals to 4 minus T value what is given here? 3 seconds. 4 minus 3. Okay. 3 square. This become as 4 minus 3 square is 9. Will become as minus 5. Okay. So for next one, what is the V1? Okay. This is V1. 4 minus v1 means what? T is equals to 1 square. What is this? 4 minus 1, it's a 3. So average acceleration is equals to, it's a minus 5 minus 3 by T2 minus T1, 3 minus 1. What is the answer? Minus 8 by 3 minus 1, 2 will become as minus 4 meter per second square. So is a method to find about this average acceleration. So negative sign indicates what? It's a negative x direction. It is acting along with the negative x direction. So this negative sign indicates, negative sign indicates, so negative sign indicates, so it acts so along with negative x-axis. It acts along with negative x-axis. First one is completed. Next one, what is the acceleration at a function of time t? So acceleration means what? Just you can take for the differentiation. Yes. So first, second one I'm talking about. So what is this? V. V is equals to, second one answer I'm doing. V is equals to 4 minus t square. Acceleration A is equals to dv by dt. This is equals to d by dt times of 4 minus t square will become as differentiation of 4 is 0 minus differentiation of t square is what? It's a 2t minus 2t. So acceleration as a function of time t, A is equals to, okay, so then A is equals to minus 2t. So what is this? Meter per second square. And for the third one, if you speak about, what is there? Instantaneous acceleration. So what is there? This. So instantaneous acceleration. So instantaneous acceleration is what? A is equals to minus 2 into t means what? 1. It's a minus 2 meter per second square. So this type of questions will be asking based on this. Okay. So this is what average acceleration as a function of time t. Okay. So like different models we can see on this. Next one, what is retardation? Yes, retardation. Retardation is negative acceleration. So this is retardation. So retardation is negative acceleration. A bar only, but minus. So acceleration is equals to minus retardation. Yes, retardation. Yes, this is what? Just negative acceleration is called what? Retardation. Whenever A is given, it should become as minus A. Minus, for example, acceleration equal to, so I'm talking about example is what? Acceleration is equals to minus 5 meter per second square. Retardation is equals to 5 meter per second square. Okay. So when retardation, when we use this term retardation, then what? Decreasing speed. Okay. Decreasing its speed. So decreasing speed means what? It's a brakes are applied. Okay. So brakes of automobile are applied. So brakes are applied, like we can write this. And about the acceleration, so one is about uniform acceleration and next one is about non-uniform acceleration. So uniform acceleration means what? If your body travels equal changes in velocity in equal intervals of time. Non-uniform acceleration, if your body travels unequal changes in velocity in equal intervals of time. Okay. So I can also talk about, that is what? Uniform acceleration. Okay. So uniform acceleration. So next, second one is about non-uniform acceleration. Non-uniform acceleration. Yes. So this is about non-uniform acceleration. Uniform acceleration. Uniform acceleration. So body travels like, that's what, equal, okay, equal changes in velocity, equal changes in velocity in a equal interval of time, equal interval of time. Yes. So this we can talk about unequal changes in velocity, unequal changes in velocity, unequal changes in velocity. So in equal intervals of time, like we can talk about. Sir, when the body is traveling with equal changes in velocity in equal intervals of time, this is what uniform acceleration. In the uniform acceleration, so we need to discuss about equations of motion. Okay. So next one is about what are the equations of motion. Okay. So equations of motion, these are simply we can discuss like, for the first one is about V is equals to U plus AT. Okay, V is equals to U plus AT. For the second one is about S is equals to UT plus half A T square. Next one, V square minus U square is equals to 2AS. For the fourth one, Sn is equals to U plus A into, so A by 2 into 2n minus 1. Distance travel means what? These are the like equations of motion, we can use it. Okay. So here for the equations of motion, V is equals to U plus AT. V stands for final velocity, U stands for initial velocity, A stands for uniform acceleration. Okay. So S is what? Distance traveled in t seconds. Okay. Careful on this one. This is what first I am giving about. So what is this? S is what? S is the distance traveled. Okay. Distance traveled in t seconds. Distance traveled in t seconds. And Sn is equals, Sn is what? Distance traveled. It's a distance traveled in what? Tth second. Okay. So it's what? Nth second. Nth second. So I can give the example for this. The example is what? For example, so if you go on it, body travels along with a straight line path. Okay. Distance traveled by body, by a body, okay, in 3 seconds. 3 seconds. We have to use S is equals to UT plus half A T square. This is what? S is equals to UT plus half A T square. For this is what? For the first one. And for the second one is what? So distance traveled, okay, by a body, same, by a body in third second, you can see a third second, here is what? 3 second. So Sn is equals to U plus A by 2 into what? 2n minus 1. This equation can be used for the nth second. Okay. So it's what? Nth second, like we can use this one. And we can also derive the equations. But for the problem solving, just we can come to know about what are the equations of motion. So next one is about, so I'm talking about what is the motion under gravity. Okay, motion under gravity. So motion under gravity, motion of a body under gravity. For all the levels, this concept is useful. Careful on this. So first one, let me know about what is the acceleration due to gravity. Yes. So this is what acceleration due to gravity. So for the first one, I'm talking about acceleration. So acceleration due to gravity. Yes, acceleration due to gravity. It's a G. Okay. So this is what is the acceleration due to gravity. My acceleration due to gravity is if a body is this dropped from a height. Body is dropped from a height, reaches the ground. Yes, it reaches the ground. So its initial velocity is what? U is equals to 0. Gradually velocity increases or decreases? Increases. The changes in velocity increasing means what? Acceleration is produced. So due to what? It's a gravity. Means towards center of the earth. Okay. This I can say you that here first. So what is the acceleration due to gravity is what? Acceleration. Okay. So this is what? Acceleration. Acceleration produces. Acceleration produces. So due to gravitational pull. It's what? Gravitational pull towards the center of the earth. Towards the center of the earth. So this is what? Acceleration due to gravity. Yes. So you know this A is equals to acceleration A is equals to G. G on the earth is equals to what? 9.8 meter per second square, and G on the moon is equals to what? It's a 1/6 of G on the earth. Okay. So if you do this one, 1/6 into 9.8. Okay. 6 ones are 6, 30, 638, 6 6 are. Okay. So approximately 1.63 meter per second square. So this is what? Acceleration due to gravity on the surface of the moon. Okay. So this is a thing about is what? It's an acceleration due to gravity. Next one, what does it mean by the term free fall? Okay. So what is free fall? You know, free fall is a concept in a schooling. Yes. So free fall. What is a free fall? Free fall means freely falling body. Okay. Freely falling body from certain height. This is what? It's a free fall. Yes. I'm talking about free fall. Yes. Now, your body is dropped from certain height. This is the body dropped from certain height. Yes. So here is the ground. This is the ground. Yes, its initial velocity U is equals to 0. So it's what? Velocity. And acceleration A is equals to plus G, because acceleration is increasing, and time taken T is equals to time of. So it's what? Descent. That's why let it be, it's a T only. Later we discuss about. Otherwise time of descent. Okay. T1 I'm talking on this. Yes. So the height from here to here, S is equals to what? You say it's a H. This is what? S is equals to H. Now, so is the what are the conditions of free fall? Conditions. Yes. So conditions of free fall. So in any case, so conditions of free fall means what? We need to follow the cases. First one is what? Initial velocity U is equals to 0. Second one is what? Acceleration A is equals to plus G. And the third one is what? Time taken T is equals to what? It's a T1. T1 is what? You say this is what? Time of. Okay. This is what? Time of descent. Okay. So time of descent. This is the time of descent. And for the fourth one is what? Here, what is the final velocity? And the distance s is equals to what is it? It's a h. Now, one by one I am talking on this. So, for the first one I am talking about, here, very first one. Sir, with what velocity body reaches the ground? What velocity body reaches the ground? Striking velocity. So, that is what? From v square minus u square is equals to 2as. What is the initial velocity? 0. What is the s? h. A is equals to what? G. V square is equals to 2g h. V is equals to under root of 2g h. So with what velocity body strikes the ground? V is equals to under root of 2g h. Okay. So for the second I am talking on this. So here this is what? What is the initial velocity? 0. With what velocity body is striking the ground? Under root of 2g h. Yes. So next one, what is the time taken to reach the ground? Time taken to reach or to strike, okay, the ground, to strike the ground. So time taken to strike the ground, it means what? This is what you say, it's a time of what? Descent. Okay, so time of descent. So we can take the equation. The equation is what? S is equals to ut plus half a t square. S means what? It's a h. U is 0 into t plus half a g t square. H is equals to, we can write half g t square. T square is equals to 2h by g. T is equals to under root of 2h by g. This is what? Time of descent. Okay. So like we can talk about, this is what? Time of descent. And next one is what? With what velocity body is striking the ground like. Okay. So in the free fall, one more type of question we may see on this. So this is what? For example, for the third one I am talking on this. This is what? Third. Yes. So if the body is in the case of freely falling, yes, what is the ratio of distances traveled in 1 second, 2 second, 3 second? And ratio of distances traveled in first second, second second, third second. And ratio of distances traveled in so first equal intervals of time, 2 seconds, 2 seconds, 2 seconds, so on. Okay, how can we write? How can we do such type of questions? Yes, so we are moving to this next page. This, so application we are taking as a question this. Okay, carefully. This is what? In the case of free fall, in the case of free fall, yes, or freely falling body, in the case of free fall, yes. So calculate. So very first one is about the calculate the ratio of distances traveled. The ratio of distances traveled. Ratio of distances traveled. Yes, ratio of distances traveled. Okay. In so first second. No. First one is what? I'm taking about 1 second, 2 second, 3 seconds, so on. So it's what? 1 second, okay, 2 second, and 3 second, so on. This is my first question. And second one is what? It's a first second, second, okay. It's a third second, okay. So this, and for the third one is about, so in successive equal intervals of time, successive equal intervals, okay. So intervals of time, successive equal intervals of time. This I need to calculate it. Okay. So for the first one, I'm talking on this here. in 1 second, 2 second, 3 second, like this one. For example, for the first one I am talking of this. What is this? In 1 second, 2 second, 3 second, like this. So for the first one solution, S is equals to what? Ut plus half a t square. Okay. In the freely falling case, u is what? 0. S is equals to what you say? Half g t square. S is proportional to t square is the relation. Yes, so I can find the ratio of distances. S1 is to S2 is to S3 is equals to T1 square is to T2 square is to T3 square, so on. This is what? 1 square, it's a 2 square, it's a 3 square. This is what? 1 is to 4 is to 9. S1 is to, S2 is to, S3 is equals to 1 is to 4 is to 9 for the 3 intervals. So for many means what we can use that. So this is for first one. For the second one I am talking as, so in the first second, second second, third second, like, okay. For the first second, second means nth second, distance traveled, yes, by the body. So distance traveled by the body, yes, in nth second. Then what do you say? Sn is equals to u plus a by 2 into 2n minus 1. It's what? U. Okay. What is a u? It's a 0. What is a a? It's a g. Right? Sn is equals to g by 2 times of 2n minus 1. This is the required relation. Sn is equals to g by 2 times of 2n minus 1. Okay. So for example, if I talk about S1, in the first second, g by 2 times of 2 into 1 minus 1 will become as what? 2 minus 1. So it's a g by 2. For the S2 is equals to, this is S2 is equals to g by 2 times of 2 into 2 minus 1. 2 2s are 4. Okay. 4 minus 1, 3. 3g by 2. So for the S3 is equals to g by 2 times 2 into 3 minus 1. It's a what? 2 3 is 6 minus 1. It's a 5. 5g by 2. The ratio of distances traveled, S1 is to, S2 is to, S3 is equals to 1 is to 3 is to 5, like we can write it. This is the ratio of distances traveled in. So in what? First second, second second, third second. So is what? In 1 second, 2 second, 3 second, like this. Okay. So successive equal intervals of time. What is the meaning of this successive equal intervals of time? Yes. So this is what for I'm talking about. Yeah, successive equal intervals of time. For the third one I am talking this. So with the example and including that I am talking about this. This is body is dropped from a height. Yes. So I am choosing this is what? It's what? From the first one is what? It's a. Okay. So this is what? It's a B. This is a C. Next one is what? D. Let it be total time taken is what? 6 seconds. Total time taken is what? So it's a 6 seconds. Okay. So my question is about successive equal intervals of time. Means what? 2, 2, 2. Okay. So that's what if I write about it's a 2 second. So this is what? 2 second. Next one is about 2 second. What is the ratio of distances traveled in 2 seconds, 2 seconds, 2 seconds? Yes. So like this. So first for the problem solving this. So we need to follow this. First one I'm talking about AB. AB. Okay. So for the AB means what? For this is the free fall case, right? Yes. What is the condition? S is equals to ut plus half a t square. What is the u? 0. S is equals to half g t square. Correct? Yes. First one I'm writing S1. S1 is equals to S1 means what? For AB, okay, half G, it's a 2 square, would become as 2 square means what? 4, 2 to cancel, so this is what? It's a 2G. S1 is equals to 2G is the first relation. Yes, it's what? S1 is equals to 2G. Next one I'm talking about S2 means what? I should go for AC. Okay, so from after getting AC, AB plus BC, then AB already there with you, S1, that can be substituted. Okay, for the AC. AC means what? What is the condition? S is equals to half G T square. S1 plus S2 is equals to half G. 2 plus 2 what? It's a 4 square. S1 plus what is the S2? So okay, S2 is equals to half G. 4 square means what? It is 16. 2 ones are 2 8s are. What is the answer? 8G. So what is the S1? S1 is what? 2G plus S2. S2 is equals to what? It's a 6G. This is what? S2. Yes. So next one, I want to talk about AD now. AD. So from AD, so same S1 plus S2 plus S3 is equals to, okay, so S1 plus S2 plus S3 is equals to half G into, what is the total time? It's a 6 square. Okay, so what is the S1? 2G. What is the S2? 6G. What is the S3? This is equals to half G into 36. Okay, 2 ones to 18s. So 2G, S3 is equals to what? 18G minus 8G. 18G minus 8G. So S3 is equals to what you write now? It's a 10G. Yes, finally our relation is about S1 is to, S2 is to, S3 is equals to, first one 2G, next one 6G, next one 10G. So what's your answer? So that is what? 1 is to 3 is to 5 is my answer. 1 is to 3 is to 5. S1 is to, S2 is to, S3 is equals to 1 is to 3 is to 5. So this is the condition for the free fall. Okay. So next one, vertically projected bodies. For the vertically projected body. So how can you discuss about now for the vertically projected body? More vertically projected body. Vertically projected body. Yes. So vertically projected body. For this vertically projected body, we should know about same the thing. When freely falling means, just to imagine you are at the, your reference point is what? At some certain height. The height is what? H from the ground. So vertically projected body means what? You are on the ground. Yes. So a body is projected. This is the ground. Body is projected like it's vertically upwards. Yes. So acceleration, this here at this position, velocity become as 0. Acceleration increases or decreases? Decreases due to gravity. A is equals to minus G and S is equals to, what do you say? It's a H. S is equals to what? H. And T is equals to time of ascent. It's a time of ascent. Okay. So I can go for, this is what it's a, this is what? Time of ascent. Okay. So is the time of ascent. And next one, with what velocity you are projecting? It's a V. V means what? Initial velocity is what? This is what? Initial velocity I am taking about U. Correct? So I am taking as it's a U. Here is the final velocity. V is equals to what? 0. My first question, with what velocity body is projected? First question. Second question is what? What is the time taken to reach the highest point? What is the maximum height? These are the things. Yes, basic questions on this. For first one is that velocity of projection. Yes, it's a velocity of projection. This velocity of projection is what? It's a U. correct? So what is the velocity of projection? I want to know about velocity of projection. How should I know? Sir, I know initial velocity, I know final velocity, even I know the conditions of vertically projected body. Yes, so from the equation I'm writing as v square minus u square is equals to 2as. What is the v? 0. What is the u? U only is equals to 2. A means what? Minus g. S means what? H. Minus u square is equals to minus. So minus u square is equals to we can go on this minus 2gh. Minus minus cancel. U square is equals to what it said? 2gh. And u is equals to, it's a u is equals to under root of 2gh is the velocity. Okay, velocity of projection is what? U is equals to under root of 2gh. With what velocity? So it strikes the ground? V. With what velocity projected? C. In free fall, velocity of striking the ground. So V is equals to under root of 2gh. In vertically projected, with what velocity projected? U is equals to under root of 2gh. So V bar is equals to minus U bar, opposite direction, right? So its magnitude is what? V is equals to U is equals to under root of 2gh is information is what? This is what about the velocities. Okay, this is what? So velocity in the case of free fall, with it strikes with the ground. In the case of vertically projected, so some velocity of projection is there. That velocity u is equals to what is it? Say under root of 2gh. Magnitude is same. Okay, so next one, we'll move on this. This is what velocities of striking ground is completed. For the second one I am talking as this. What is the time taken? So time taken means what? Time of ascent. Okay, time of ascent. So what is the time of ascent? TA. Yes, time of ascent. From the equation V is equals to U plus AT. What is the U? Yes, U means what? It's a U only under root of 2gh. Yes, so V is what? It's a 0. A is what? Minus G. 0 is equals to U minus GT. Minus U is equals to minus GT. Then T is equals to what? U by G. You know, this is what? Time of ascent. So in the absence of air resistance, time of ascent is equals to time of descent. Okay, so this is what? Time of ascent is equals to time of descent is equals to U by G. Yes, so if we speak about what is the time of flight? Yes, so time of flight. Time of flight means what? Flight. Flight means what? In air. How much time it remains in the air? How much time the body remains in the air? Body projected. Yes, again returns to the ground. Yes, this is the ground. Time of ascent, time of descent. Time of flight is equals to T1 plus T2. It's what? U by G plus U by G. What do you say now? 2U by G. It's a time of flight. This is what? It's a time of flight. Time of flight is equals to T is equals to 2U by G. Okay, so this is about here about time taken to reach the highest point. And for the third one is about what is the maximum height reached by the body. So maximum height means what? This is what? Maximum height reached by the body. Yes, reached by body. Maximum height reached by the body means what? It means what? Maximum vertical displacement. Correct? Maximum vertical displacement. So in this case, body projected. So this velocity is there. U, we got it. This is what? Under root of 2gh. A is equals to minus G. And S is equals to what? H. What is this H we are going to find? Here final velocity is 0. Okay, so from the equation of motion v square minus u square is equals to 2a. Yes, v square minus u square is equals to 2as. Now, what is the v? 0. What is the a? Minus g. Minus u square is equals to minus 2gh. U square is equals to 2gh. H is equals to u square by 2g. Maximum height is what? H is equals to u square by 2g. This is the condition for vertically projected body. The most repeated questions from this: what is the velocity at half of the maximum height? What is the velocity at 1/4 of maximum height? Like these questions will be asking. Yes. So what is the velocity? So velocity, for example, I'm finding about velocity. Okay. This is what velocity at half of maximum height. Okay, I'm showing one case, remaining you can do this one. So velocity at half of maximum height. Yes, this is maximum height. Yes, let us see about what is the velocity at the half of maximum height. Yes, so now here velocity at the half of maximum height is what? Body projected vertically upwards. Yes, so this is what? Initial velocity u. Here is what? Final velocity v is equals to 0. It's what? S is equals to what? H. This is what? Maximum height. My question is what? At a half of maximum height. Half of maximum height means, for example, exactly at this point. This is what? Vertically projection. This height is what? It's a h by 2. It's a h by 2. Yes. So at a half of maximum height, what will be the velocity? Let it be, this velocity is what? v1. Correct? It's a half of maximum height means this velocity from the equation v square minus u square is equals to 2as. V means what? v1. Correct? U is what? It's a there. A means what? Minus g. S means what? h by 2. S is what? It's a h by 2. v1 square minus u square is equals to 2 minus g. It's a h by 2. 2 to cancel. v1 square minus u square is equals to minus g. H means what? U square by 2g. v1 square is equals to u square minus, okay, so this is what? G and g cancelled, u square by 2. v1 square is equals to u square by 2. v1 is equals to u by root 2. What is the velocity at half of maximum height? U by root 2. Just to check about, at this point I want to know, so I have taken as v square minus u square is equals to 2as. So this is the v1 and u. v1 square minus u square equal to 2. A means what? It's a minus g. S means what? h by 2. Okay, so this become as v1 square minus u square 2 minus g h by 2. And v1 square minus u square equal to g and g cancel, minus u square by h means what? U square by 2g. So v1 is equals to what is the condition? U by root 2. So like this, in free fall and vertically projected bodies, so motion under gravity, we can solve the problems based on this. Thank you.